Okay, so looking at it, expected value. So this is part probability, and it's just kind of a recap, just so you can look back over it. So expected value is an average outcome of an experiment. So the key word there is average outcome. It's just, and just remember expected value. So average outcome of an experiment. So what it does is it shows us if an experiment is fair or unfair. So say if you go to a fun fair and you're gambling money, you're just figuring out whether it's actually fair, it's unfair to put the money that you are towards the game. So its symbol here is the e to the x, so that's the symbol for expected value. So make sure that we recognise that, because they may ask us to calculate the expected value, or they may just say calculate e to the x. So in order to calculate expected value, so we find the probability of each event occurring. So we all know how to do that. So like, what's the probability of getting a 6 on a dice? Well, we know the probability of getting a 6 on a dice is 1 over 6. So that's the first part. Calculate the probability of each event occurring. So multiply this probability by each outcome, and then add all these answers. So in other words, a quicker way to do it is you find the sum of the outcomes by the probabilities. Okay, so we know probabilities, and what is outcomes? Well, outcomes is just literally what they have here, like the number. So instead of number here, we can just write outcomes if we wish. Is that okay? It's the exact same thing. So in this question here, so this is an exam paper question from one of the years recently. A dice is used in the game. The probability of getting 6 different numbers on the die are shown below. So instead of using fractions, they actually use decimal, and that's okay. That's fine. We know that 0.25 as a decimal is just 1 over 4 as a fraction. So it's the exact same. You could transfer them into fractions, but there's no need. Right, so in this question, they've actually calculated our probability first. They've calculated, or they have our outcomes written first, which they always will have, and they want us to find the expected value. And we know from early on how we find the expected value is we find the sum of the outcomes by the probabilities. So we're going to do that now. So the sum means that we add. Sum means you add them all together. Of the outcomes by the probabilities. By means multiply, obviously. So outcome by probabilities. So our first outcome is 1. I got that here. Multiply by a probability, which is 0.25. That's 0.25. Sum means we add them all together. Next outcome is 2. Multiply that by 0.25, because that's its corresponding probability. Plus 3 by 0.15. Plus 4 by 0.15. Plus 5 by 0.1. Plus 6 by 0.1. And just to explain to you why the probability isn't a sixth, a sixth, a sixth, a sixth, a sixth, a sixth. Reason being, like, if we were to say what the expected probability would be, we'd say it's a 6. But generally, if we were rolling a dice, say we roll a dice 6 times, we're not going to get a 1, a 2, a 3, a 4, a 5 and a 6 in them 6 rolls. We could get 3 6s, we could get 1 1, we could get 1 2, and we may never get a 3, a 4 and a 5. So that's why the probability is a bit different in this case. So just, I'll input all this into my calculator. So 1 by 0.25 plus 2 by 0.25 So just to realise that the number are the outcomes. And sum means you add them all up. And this is expected value. So that gives us 29. Second. So it gives us 2.9. It's 29 over 10. Oh, sugar. (29 over 10), which is equal to 2.9. So the expected value of this game is 2.9. That's as easy as it is. Just look at another example. So say they give us a spinner like so, and they say find the expected value of the spinner. So we know that we have to get the outcome and the probability. And we know that in order to find the expected value, we multiply the outcome by the probability and find the sum of them. Okay, so like our first outcome here, so looking at this spinner, so the first one is $1, second outcome is $5, and the third outcome is $20. So they're like our outcomes, just like rolling a 1, rolling a 2, rolling a 3, and so on were our outcomes. What's the probability of the spinner landing on $1? Well, you can see it's split into thirds. So the probability of getting $1 is a third, probability of getting $5 is a third, the probability of getting $20 is a third, because the spinner is actually split into thirds. Okay, so how do we find the expected value? Well, we get the sum of the outcome by the probability, and that's how we do it. So what is the outcome? So we've 1 by a third, sum means plus 5 by a third, plus 20 by a third. And when we put this into our calculator, that is going to give us our expected value of playing this game or spinning this spinner. So the expected value will tell us how much they'd need to charge for us to play the game in order for it to be fair. So just bear with me. Right, so it says that is 26 over 3, which is equal to 8.6. So 8.67. So in order for this game to be fair, they would want to be charging us $8.67. Now, and I hope you understand that. So that's what expected value is. And in order to be fair, they'd want